Good morning, everyone. In this video, we will discuss about the equations in quadratic form in au squared plus bu plus c equals 0, where u is an algebraic expression and a is not equal to 0. So for example, we have it here. For example number 1, we have x raised to 4 plus 5x squared plus 4 equals 0. So sa unang tingin pa lang dito, this is not really a quadratic equation or expression because of the highest exponent, which is equal to 4. However, we can rewrite this into a form like quadratic equation. Since x raised to 4 can also be written as x raised to 2 times the exponent 2, so it looks like a quadratic equation now. Since we have here 2 as the highest degree of our equation. However, we will not forget that we have also x raised to 2 here. That's why we will do some substitution. Okay, for example, let x raised to 2 be equal to u. So, instead of writing x squared here, we will substitute u. So, u is equal to x squared also in our substitution here. So, u raised to the exponent 2, the exponent outside the parentheses, plus, since ang x squared natin, sinabi ko kanina, papalitan natin siya ng u. So, therefore, instead of writing x squared here, we will write u plus 4 equals 0. Or, we can also make use of some other variables present in the alphabet. For example, let x squared be equal to t. So, we have, instead of writing x squared here, we write here t. So, t raised to 2 plus 5t plus 4 equals 0. So, after that, we can now factor this equation, since we can now directly say that this is a quadratic form of equation because of the highest degree, which is equal to 2. So, this is the way I factored out my equation, which is t squared plus 5t plus 4. I also introduced this to you in our previous video. So we have here the factors of the first term, which are t times t, the factors of the last term, which are 4 times 1. So we should also consider the middle term in finding the factors of our extremities. So we have t times 4, we have 4t, t times 1, we have t. So we will add 4t plus t. It will give you 5t. This is just for checking if the sum of the products of our factors at both sides is equal to the middle term of our given equation. Since they are equal, they are equal, therefore the factors are correct. So we will just pair them up. So the t here is for the value on the bottom right corner, and the t on the bottom left corner is for the value on the upper right corner. So we have now t plus 4, t plus 1 is equal to 0. Then, for us to find the value of our x's, we will now substitute again the x squared into t. So substitute x squared for t. So instead of writing t here, we will now substitute x squared. So we have x squared here plus 1, another x squared here plus 4 equals 0. And now we will try to find the values of x using the process of extracting square roots. So we have x squared plus 1 equals 0, x squared, and we will transpose or transfer the value of positive 1 into the other side of the equation. That will give you negative 1, or we can apply the addition property of equality if you want to. And also, for the other value of x, or values of x, we have x squared plus 4 equals 0. Again, transfer positive 4 in the other side of the equation. It will give you negative 4. And for the continuation, we have here, since we're going to extract the square roots here because of the exponent 2, we will do it in this way, using this process. So we already enclose the x squared into a radical symbol with index 2. So x squared of x squared is x. Take note, don't forget to write the positive and negative here. So we have here positive and negative square root of negative 1. Take note of the negative numbers or negative radicands under a radical sign. If you have a negative radicand, and if your index here, since we have index, you cannot see 2 here. 2 refers to the index because the base of a radical expression, the base of the index is 2. So we will not write any more 2 here. It is understandable that if you cannot say any number, it is 2. There is 2 here. So square root of negative 1. If your index is even and your radicand is negative, the answer should have I. But if your index is odd and you have negative radicand, you will not anymore use I. Instead, you will just directly write negative sign. So for example, we have square root of negative 1. Square root of negative 1, since square is even because of the index here, take note, since this is written in the square root is written on this way, there is 2 in the index. However, in the radical expression, we don't write 2 anymore. It is understandable that there is 2 here. So it is even, and the radicand or the number or the value inside your radical symbol is negative. So therefore, it will give you I, since our value here is negative 1. So square root of negative 1 is I. So we have positive and negative I. Next, square root of negative 4. Square root of positive 4 is 2. However, we have negative, so we will write I together with 2. So we have positive and negative 2I. Okay, so bibigyan ko naman kayo ng example. What if yung ating index ay odd, tapos even yung negative yung ating radicand? For example, we have cube root of negative 8. So kagaya ng sabi ko kanina, kapag ang ating index ay odd, tapos ang ating radicand ay negative, you don't need to write or use I. Instead, you will use negative sign directly. That's the rule. So what is the cube root of 8? That is 2. So 2 times 2 times 2 is 8. However, we have negative, so we will just directly write negative 2. Again, the cube root of 8 is 2. However, we have negative here, so we will just directly write negative instead of I. Gagamit lang tayo ng I kapag ang ating index ay even. Kapag ang index natin ay odd, hindi na tayo gagamit ng I. Instead, yung negative na lang yung gagamitin natin. Take note, I is the I denotes imaginary numbers. Again, I denote imaginary numbers. Take note of that. So, moving back to our discussion about the values of x, we have now the 4 values of x. Take note, in our original equation, we have here 4 as the highest degree of our equation. So therefore, it simply means us that we have 4 values of x. So if you don't have 4 values of x, your answer is wrong. So we have here now 4 values of x. So in this side, we have x is equal to positive and negative I. So we have actually here 2 values. So we have x is equal to positive I and x is equal to negative I. And here we have 2 values also, which are x equals to positive 2I and x equals negative 2I. So we have now the roots or the values of our x's. So we have here another way of solving for the values of our x. If you are not comfortable using the trial and error method in finding the factors and values of x, you can also make use of the quadratic formula if you want to. However, this might took you so long because this is very long compared to the factoring method. So here we have this we have the t squared plus 5t plus 4 equals 0. This was taken from our first example, wherein we already substituted here t for x squared. So we will just identify the values of our a, b, and c. So a, b, and c are the numerical coefficients, the constant numerical coefficients of our terms. So a for the first term, b for the second term, and c for the third term. So a is equal to 1. This is the number beside t squared, or the first term, and b is equal to 5 together with t, and c is the third term, the number without any variable. So we have now 1, 5, and 4 respectively. So here we are used to see here x, but here in our equation we cannot see x. Instead we have t, so we will just substitute t here, and in our later solution we can see t because we will substitute it again. So we have t is equal to negative b plus and minus square root of b squared minus 4ac over 2a. This is the quadratic formula. And next, we will just substitute the values that we have, which are 1, 5, and 4 respectively. So we have negative b, so negative times 5, we have negative 5 plus and minus square root of, we have here square root of b squared. So ang b natin is 5, so 5 squared is 25. Next, we have 4 times 1, this is a, times 4, this is c, over 2 times 1, again, this is a. So we have now negative 5 plus and minus square root of 25 minus 16. Saan ang galing si 16? So, ang 16 nang galing dito kay negative 4, or 4 times 1 times 4. So we have 16 here divided by 2. Next, we have negative 5 plus and minus 25 minus 16 is 9. So we have square root of 9 divided by 2. And now we have square root of 9 is 3. So therefore, we have negative 5 plus and minus 3 over 2. So from this point, we will now divide the possible values of our t. Since here, t pa lang yung nakikita natin, mamaya pa yung x. So we have now t is equal to negative 5 plus 3. Again, negative 5 plus 3 over 2. So negative 5 plus 3 is negative 2. So we have it here, negative 2 divided by 2 is negative 1. So tigil muna tayo dito. Dito naman tayo sa kabila. So t is equal to negative 5 minus 3. Since nakuha na natin yung positive kanina, or addition, subtraction na naman. So negative 5 minus 3. So we have minus 3 over 2. Laruin lang natin. So over 2, or divided by 2. So negative 5 minus 3 is negative 8 divided by 2. We have negative 4. So from this point, or from this stage of our process, we can now directly substitute x squared for t. Kagaya lang nung ginawa natin doon sa unang method natin. So we have x squared is equal to negative 1. Tapos, nag-apply lang tayo dito ng extracting square roots. So, we still have the same answer. Positive and negative square root of negative 1 is equal to positive and negative I. Positive and negative square root of negative 4 is equal to positive and negative 2i. What's the advantage of using quadratic formula is that you are sure of your process, and you can directly find the answer by just following the process. You just need to identify the values of a, b, and c. After that, just plug it into your equation or your formula, which is the quadratic formula, and do the process until you find the answer or the values of x. Take note, class, the values of x or the variables are also considered the roots of the equation or the zeros of the equation. Again, the values of x or the variable are also considered the roots or the zeros of the equation. Because sometimes you will be asked to find the roots of a certain quadratic equation or polynomial equation. If you are asked to do so, you are just finding the values of the variable present in the equation. Take note of that. So we have now the values of our x using the quadratic formula. You can make use of completing the square if it is applicable, or quadratic formula, or the factoring method. It's up to you.